the shear locations. Well, look right there. Where did they? You have a lot of members going on the top, and look right at the end where it's bearing on top of the wall. Do you guys see that? What's going on right where the truss hits the wall? What's happening? What do they do?
They put like a metal brace around.
There's a brace, but there's if you look right all the way up there at the end, there's more material up there. Right at the end, they put some more angles all the way at the end. You can see where the truss hits the wall. Okay, you can see it on that side as well. They added material to here and here. Okay, because what would make this stronger to stop it from snapping? What can I do to this?
Put something at the end.
Put something in there. We can make it thinner or thicker.
Okay.
Thicker. We can make it thinner to stop the shear. So what they did with that there was they added material at the end of the trusses. So that's something you guys should be thinking about when you build your own trusses. Okay, so there's some things that you can build up when you build your own trusses. Okay, so I'm going to give you guys two little hints from my end. All right, when you build your trusses, a couple things you guys got to think about again: pressure, tension, and the other big thing is, I'm going to put this up here. My number one thing is going to be the connections. When you guys built these last year, for those that did, where did it mostly fail?
On the road, the joints.
The joints. All right, the joints. Okay.
Joints on the roadway.
The joints on the road. That's the number one thing. The connections. Okay, so that's what you guys got to be thinking about when you build your trusses. How can I make the connections better? And I read the little pamphlet. They have some good ideas in there. So that's one thing that you guys can think about. The other thing is, I'm just going to write this down. You know, top chord bearing. I'm not really going to talk about it, okay? You know, bar joist. I'm not going to talk about it, but it's a hint, okay, for you guys when you're trying to do these things, of maybe some of the things you can think about when you're doing that. So these are the things we're going to start thinking about, guys, when you build your trusses. When something does fail, do you guys watch the news, right, or know about the news? Can you guys tell me about anything that's structurally failed? Think about it, yeah. I mean, here we are. You may think of anything in the news? Anything? What else?
Aren't they trying to fix a lot of bridges because they're getting old?
A lot of bridges, yeah, because they're getting old. Yeah, that's correct. Yeah, there's a problem, especially in the state of Texas, because when they built all the roads in Texas, most of them, the big bridges and stuff like that, was about 60, 70 years ago. Okay, and now all those bridges are starting to become damaged.
In San Francisco, there was a bridge, I don't remember what it was called, but it fell down.
Oh, yeah.
You know, because of the earthquake. Okay, yeah, they collapsed one on top of the other, right? Okay. Now, when you guys saw that, I don't know if you can remember, if you think about it, you know, did it fail like right in the middle of the beam, or did it fail at the ends where it was connected to each other? A lot of times it's failing at the connection points. Okay, so when you guys are building these bridges, okay, you're going to build them to failure, which means you're going to build them to break. Okay, and so when that happens is when the weight gets put on, it's going to find the weakest spot. You could build the greatest truss in the world on this side and on the other side. Because remember, you guys who did it before had those parallel trusses. Okay, but if you make one bad connection, doesn't matter. Mrs. Maggio tells me a lot of times what happens to the weight. Where does it go?
Through the road.
Right through the road, right? The trusses are still there. But what happened was some of the connections is what failed. Okay, so those are some things that you guys can think about when you're doing that. Connections are really critical. Don't forget about getting the weight from the block over to the outside to the two trusses. That's one of the more important things that you guys can do. Okay? Another thing is, I always give this advice. I gave it to the last class. Look up. Okay, look up. You know, look at that truss. That's a prime example of one of the things that you guys can be using anytime you kind of have a question about what you can do. The other thing I told you about the other class was we worked on a little bit. Now, if I make a connection between the two, what connection do you think is stronger? That's kind of broken. This kind of connection, or if I made this connection?
That one.
Right. Okay, so these kind of connections, a little butt connection is it's called a butt connection, yeah, I know. Okay, it's right there. That's going to be, there's not much surface area between the two. But if I turn it over to the side, there's a lot more area that I can get that glue on there and working. Now, look up. Okay? Is there any connections in that truss that look like this?
No.
No. What do you see all the connections look like?
All of that.
Like this. Okay? So those are some things you guys can think about when you're building your trusses. Okay? All right. So, now it's a good opportunity for you guys to ask me any questions you want. Okay? About trusses or what you guys are going to do when you build your trusses. Now,
Like, would it be possible to attach like 2 ropes in the very center and have them connected to points like on the middles of the table, pulling the center upwards?
now come draw a picture of it.
In this, in our thing, you can't use anything except for balsa wood though.
No ropes, right?
No ropes.
So that's a rope.
Or like a piece of balsa wood or something where you pull the weight up from the middle?
That's right. That's what you're going to be doing. If you're going to be pulling the weight up from the middle. Is this, so this, am I looking at the bridge from the side? Okay, yeah. So you're basically building this trusses here, and that's the point where it's going to be putting on. The other class had a good questions because I'm going to erase something real quick. Make sure you guys know what they know. You don't want them to have more information than you guys, right? That wouldn't be cool.
Give us more information than them.
Yeah, okay. Well, you guys gotta ask good questions, though. You guys have to ask good questions. So here's sort of the truss. I'm not gonna draw anything, and then there was sort of a,
I'm gonna put the dimensions back there.
oh yeah, put that one up right there. Did I pull this down? Need to pull this down?
Not if you wanna draw on it, it'll go right on the board, or you can pull that down.
Let's keep it up there.
No, it's still gonna go on the board.
Okay. You can put it on the board. Okay. And there's a, what is this called?
It's something sub.
The substructure? Okay. So a lot of times we're able to put the weight, where do you guys put the weight? Like right up here? You tie it off. You have the 30 strings, right? So where does it break most of the time? Right about here, right? So, what are some things, we have two trusses going this way, okay, and we need to get the weight from the block out to the trusses. How can we do that? What should we use? What could we use to get the weight from the block out to the trusses?
A substructure?
The substructure, yeah, but what can we put in there, okay, to get the weight over? So we got the weight going from the table to the table, okay? But now we have this thing, the block usually goes right through the middle. So what can we do?
Make a triangle going outwards towards the trusses.
Okay, yeah, there we go. We can build, a triangle is used in what sort of thing? In what we can use a truss to get out to the trusses. Okay, we can use 2 trusses going in and out of the board to get to this truss that's over here, and the substructure truss. Okay, that's one thing you guys can do, because a lot of times people try to put one little thin member from truss to truss, and what happens? Snaps right in the middle, and it drops down. Okay, so again, one of the most efficient things we can use is a truss. So let's use that as many times as we can. We can use a truss up here, we can use a truss down there, we can use a truss going in and out of the board. Okay, so those are some things you guys can think about when you're building. Anybody else have another question? I'm trying to tell you if I think, if I told them anything different. No, it's up to you guys to start thinking. There's always again, how many people did the bridge last year? All right. All right. What else? What was the highest weight of the truss? Or the bridge?
Only
bridge.
90 pounds?
90 pounds. Okay. And did you guys do the ratio between?
We can talk about that, but they both in front of them. It's a strength to weight ratio, so just because it holds the most, you have to, we know if you just built it like solid, I mean, it would hold more, but you have to think of it in terms of the construction costs like he was talking about. We're not making you pay for it, but instead we're saying, you're gonna do a ratio, you're gonna divide how much it weighs by how much it holds, where it breaks. And so, if it weighs a lot, I remember actually that's what Grayson, when our son did it when he was in sixth grade, the older son, his held the most, but it weighed too much.
Ouch.
And so when they divided it to get the ratio, he lost. Because his held a lot, but it would have cost a lot to build because there was too much material on it. So you have to make it hold as much as it possibly can for the least amount of materials, so that it weighs the least. That's why also, you talked a little bit about glue, like keeping the glue on it, how that doesn't help, like,
Yeah,
because it weighs a lot, the glue
Right.
weighs a lot.
right, so the
So some
glue,
people try to like sop a ton of glue on it, but the glue weighs more than the members do, than the balsa wood.
yeah, somebody asked in the last class if they coated every member in glue, would it help? The answer is yes,
Heck yeah.
but then it weighs so much that it wouldn't be worth it. Because remember, weight in this, means money, okay? The more it weighs, the more material you're buying, the more you're gonna cost your owner. Another thing we talked about was, if I make the member taller, okay, does that make it stronger or weaker?
Weaker.
If I make the member taller, okay, in this case scenario, we talked about the I-beam, okay, and this beam down. So which beam is stronger, this one or this one?
The shorter one.
Or B?
A.
They think that's stronger, because why?
Because
Because
it
it's
doesn't
less
have as much
Hmm?
materials to
Stretch.
pay.
There's not as much stress on the middle.
Okay. So we're looking at it at cross-section, right? So if I have a 2x10, a piece of wood, that's a 2x10, and I have a 2x12, what do you think is stronger?
2x10.
See, then, it's actually the opposite. The taller you are, the stronger it's going to be. Because we're talking about a member, I'm gonna show it the same direction as here. If we have a member that's this big, okay, we're looking at it from the side, and then a member that's taller, the taller member is gonna be stronger in bending, because that's what you get to think about. So if we made these trusses and we made them taller, it's actually going to be stronger. Okay, the farther the top and the bottom get from each other, the stronger the member is gonna be. Okay? That's another thing, so when you guys are building your trusses, the taller you make them, the stronger will they'll be, but I think one of you guys were thinking of, the less stable it would be. Okay? Because remember we kind of talked about sort of the same thing as this. So less stable, the more likely it's gonna wanna rack back and forth. Okay? The more able it's gonna wanna
And
bend.
in that
sort of-
little packet that there, did you guys read the packet yesterday, did we get that far?
No.
Okay, yeah, they didn't do that part yet, they haven't opened the packet, it talks about racking,
Okay.
and then how you put the diagonal on it.
Okay, so look up here, do you guys see, you guys didn't read that yet though, right? They said they did read it.
They didn't, they're.
Yeah, so what you can do to stop these things from racking back and forth is put some members in. If you guys look at the two trusses that are up here. Do you guys see any members that connect this truss to that truss? You see any? Okay, there's another idea. Because this is gonna be kind of what yours is gonna look like. Imagine this thing with a weight in the middle pulling down, okay? But if they didn't have those in there, it would wanna rack back and forth, okay? So there they are. That's another idea.
You talked about, at that point, did you talk about putting the numbers next to each other?
Yeah, we talked about this point here, the shear point, and what to do at the end, making the members thicker. I think she was on the phone. Okay, anybody else have any other questions? Nothing. All right.
So is the substructure always make it stronger?
Will the substructure make it stronger?
Or
Yes.
would there be any reason not to use a substructure?
If you can make the top structure very efficient, then yes. I mean, it might be also good not to have top structure, only a substructure, if you think about it, okay? Again, I don't think there's a rule that you have to have it, all right?